Assalamualaikum. My name is Nur Zahira binti Muhammad Mubarak and my entry number is B122320064. So today I'm going to present my assignment. The title is Design and Simulation of Mobile Communication Network for Kundasang, Sabah. So first, I will explain for the phase 1, area study and compliance. So first, the location is Kundasang, is a hill station and town in Kundasang, located in Ranau district along the Kundasang Valley. The distance is approximately 6 km from Kinabalu National Park and 15.6 km from Ranau Town Centre. Elevation about 1,900 meter above the sea level, making it highest settlement in Malaysia. Climate, cold climate with misty landscape and rolling green pasture, unlike the hot tropical lowlands. For the scenic attractions, offer a panoramic view of Mount Kinabalu, 4,095 meter, the highest mountain in South Asia, with the famous sunrise view. For the geology, located at the intersection of Quaternary Regional Fault Zone, underlined by the Crocker Formation and Trasmedi Formation with low quotient, high friction angle soil. The population is a rural mountain area with low population density. Economy mainly based on agriculture, dairy farming, tourism, small business, and the attraction for tourism is popular destination include Desa Dairy Farm and Kinabalu National Park. So for the user behavior, the communication pattern in Kundasang mix of resident tourism with distinct behavior of pattern. For the resident, which Kundasang is a key mukim, had a total population of around 85,077 resident as of 2020 year, with the vast majority being ethnic Dusun, engaged subsistence and commercial farming. So for the tourism, Kundasang attract thousands of tourism year-round, drawing both domestic and international visitors to the proximity to Mount Kinabalu. Heavy usage of GPS navigation, social media upload, video streaming, online booking, video call. So for the Kundasang specific traffic analysis, 5 to 7 the traffic type is early search. So for 7 to 9, tourism morning bus, 10 to 12, moderated peak, 12 to 3, moderated sustain, 5 to 8, evening resident peak, 7 to 10, highest congestion, weekend and public holiday visitor search. So for the demographic needs, residents needs agriculture digital tools, WhatsApp for their first communication, and disaster alert. For tourists, navigation map, social media, uploading emergency communication. And the physical obstacle in Kundasang is step steering, elevation, prison mist fog, annual rainfall, landslide, dense forest canopy. So for the regulation and safety framework, we have MCMC regulation. CMA established 4 tier of license regime: NFP, NSP, ASP, CSP. So key license rules: NFP must obtain a network facility installation permit from MCMC before construction. Minimum 40-day advance written notice to landowner before any survey or installation. All equipment must be certified by SIRI. Spectrum use without MCMC assignment is a criminal offence under CMA. So radiation explore limits regulated under MSEFRI. Malaysia Airlines limit to IC and IRP, public exclusion zone around tower enforced. For infrastructure safety, tower cable must be enhanced in GI pipes, solar backup system, latency tower equipment must meet IP65. So global standard, we have ITU, ICNI RP, IEEE, 3GPP, WHO. For the ethnical legal risk, land dispute, native customary rights, community objection, EMF health concern, and environment and UNESCO buffer zone. That's all for me.
Hi, Assalamualaikum, and my name is Nur Aisyah Tiraso. So now I will continue for the phase 2, which is infrastructure and safety design. In this phase, we propose the network infrastructure for Kundasang and explain the safety measure to ensure the network is reliable, efficient, and suitable for the mountainous environment. So for the network architecture, we propose a heterogeneous network, which is a headnet that combine for 4G LTE and 5G NR. This approach is suitable because Kundasang has hilly terrain, tourist attraction, and rural residential areas. So to provide wide coverage, we propose for micro cell towers at Kundasang Town Centre, Desa Dairy Farm area, Mesilau Highlands, and the Ranau Kundasang Main Road corridor. So these locations are selected to maximize network coverage and reduce coverage gaps. So we use 3 frequency bands, which is for the 700 megahertz for wide coverage in rural and mountainous areas. For 1800 for megahertz to increase network capacity in populated areas. And the last one is the 3500 megahertz for high speed 5G services at tourist hotspot. Besides that, for the small cells are installed at location with high user traffic, such as Desa Dairy Farm, hotels, market, and Kinabalu Park entrance. This help improve indoor coverage and reduce network congestion during peak tourist seasons. For the backhaul network, which is for the fiber optic, is used as the main connection because it provides high speed and high capacity. So the microwave link are used for remote areas where fiber installation is difficult. And then for the VSAT, it's a backup communication system during fiber failure or natural disaster. So this ensures continuous to the network connectivity. And then for the performance strategies to improve network performance, there are several techniques applied. So for the first one is the cell sectoring. It's a divide to each tower into 3 sectors to increase capacity and reduce interference. So the second one is the beamforming 5G to focus the signal directly toward users, improving signal quality. And then we use the frequency reuse and dynamic power control to improve spectrum efficiency and reduce interference. So the last one is we use the repeaters to install in valley and remote areas to eliminate dead zone. Besides the performance, safety is also an important part of our designs. So the network includes the strong tower structure with a fire protection system, and then the lightning protection using such protection devices and grounding system. Then we use the reinforced foundation and IoT sensor for landslide monitoring, with the weatherproof and corrosion resistant equipment, the CCTV, fancy and restricted access for physical security. And then the backup power system to using the batteries, generator and solar panels. And the last one, we use the environmental compliance through the environmental impact assessment EIA and MCMC guideline. So this measure ensure the network remains safe, reliable, and operational even during extreme weather condition. So the closing is in conclusion. Our proposed infrastructure is combined 4G LTE and 5G NR. So supported by project tower placement, hybrid backhaul, performance optimization technique, and comprehensive safety measure. So this design is expected to provide reliable, high quality mobile communication service throughout the Kundasang. So that's all from me. Thank you.
A very good morning to Madam. So I'm going to present for the phase 3. I'm Muhammad Aswari bin Jafar. So in phase 3, we evaluated the proposed mobile communication network for Kundasang using MATLAB simulation. The objective was to verify whether our network design from phase 2 can provide reliable coverage and good signal quality in a mountainous rural environment. So for the simulation setup, we use the Okumura Hata rural propagation model because it is suitable for rural and mountainous areas like Kundasang. So as we can see, the simulation evaluates the three important performance indicators: path loss, received signal power, and signal to loss ratio, signal to noise ratio, or SNR. These parameters allow us to determine whether the proposed network can provide sufficient coverage throughout Kundasang. So for the first graph, this graph shows that path loss increase as the distance from the base station increases. Among all frequencies, 700 MHz has the lowest path loss, meaning it provides the widest coverage, while for 1800 MHz provides moderate performance, while 3500 MHz experience the highest path loss, making it suitable only for shorter distance, high capacity communication. So therefore, 700 MHz is the best choice for rural coverage, while 3500 MHz is better for tourist hotspot requiring high-speed internet. For the last graph, coverage analysis. So a coverage threshold of negative 95 dBm was used. Result: most locations within 20 km are covered. Signal become weakest near the cell edge. To improve the coverage, we need to repeaters in small cells, especially in various tourist attraction and rural village. So conclusion is, overall the proposed heterogeneous network provides reliable coverage across Kundasang. Based on the simulation results, we recommend using 700 MHz as the main coverage layer for rural and mountainous areas. The 1800 MHz then should be deployed to increase capacity in populated locations, such as Kundasang town, while 3500 MHz 5G and our small cells should be installed at tourist hotspots like Desa Dairy Farm and Kinabalu Park. In addition, micro cell towers with height between 40 and 50 meters. Together with beamforming, repeaters, and dynamic power control can improve coverage while minimizing interference. That's all from us. Thank you.